you guys today. So today we're going to do some derivative questions. So it's basically an introduction to the derivative, and we will go further on the probably like few days later on the derivative this concept. So before we start, we should know what is the definition of a derivative. So derivative of f at x denoted by f prime of x is defined by f prime of x equals to limit as x approaches to 0 of f parentheses x plus h minus fx over h. So basically provided that this limit exists, the derivative of function f gives a slope of f for any value of x in the domain of f prime. Alright, so let's see the first question. Find derivative of f of x equals to x squared minus 5x at x. So first thing we should do is we write f prime of x equals to a limit as h approaches to 0. And then we do, so it's h and fx plus h minus f of x. It's basically same as the definition formula above. And then we plug the actual number into it, so it's limit h approaches to 0, and f of x plus h, it should be, we just plug x plus h to the x, which is x squared x plus h squared minus 5 times x plus h, and then minus f of x. F of x is just 2x, it's just x squared minus 5x over h. And then we simplify this on this fraction, we get limit h approaches 0, h x squared plus 2xh plus h squared minus f minus 5x minus 5h minus x squared plus 5 squared. And then we notice that x squared easily cancel out, and and 5x cancel out. So what we left is limit h approaches 0, 2xh plus h squared minus 5h over h. Then we can cancel the h out, which we left is limit h approaches 0, 2x plus h minus 5. So 1 is limit as h approaches 0, so this one should be 0. So we left is 2x minus 5. Alright, the next one. Find derivative of fx equals to x squared minus 3x plus 5 at x. So we do the same for the first one. We just use f prime of x equals to limit as h approaches 0, h over f x plus h minus f of x. And then we plug the number into it, so we got lim h approaches 0 h, so we plug x of x plus h to the x. We should represent x by the x plus h. And then we minus a normal f of x. So we got limit as h approaches 0, h x squared plus 2xh plus h squared minus 3x minus 3h plus 5, and then we minus an original function, which is minus x squared plus 3x, then minus 5. So 5, negative 5 cancel out, negative 3x, positive 3x cancel out, x squared and negative x squared plus cancel out. So what we left is limit as edge approaches 0. We left it, the denominator we left 2x edge plus h squared minus 3h, and denominator is just edge. And then we cancel the edge out, which is limit as edge approaches 0, which is, what we left is 2x plus edge minus 3. So as limit as edge approaches 0, so this one goes to 0. So the function becomes into 2x minus 3. Alright, so that's the derivative of the function of f of x equals to x squared minus 3x plus 5 at x. Remember, it's a derivative of the function at x. Alright, let's do the next one. Find the slope of a tangent line to the graph of f of x equals to x squared minus 5x at x equals to negative 1. So for this one, the tangent line of the slope to the graph, the slope of tangent line into the graph. So it basically asks us to find derivative or the instantaneous values when x equals negative 1 for this function. So what we should do is we find the f prime of x first, and then we plug into the negative 1 to it, which is becomes f prime to the 1, f prime of 1. Alright, so we just find out the f prime of x, which is our derivative first. So we got limit as h approaches 0, and fx plus h minus normal fx and over h. So it equals to limit as h approaches 0, and we plug the x plus h to the x. So we got x squared plus 2xh plus h squared minus 5x minus 5h, then minus original function, which is x squared plus 5x over h. So we can cancel out. So we cancel out the x squared with a negative x squared. Negative 5x with positive 5x. So we left its limit as h approaches 0, and 2xh plus h squared minus 5h over h. So we cancel out the h because they both have the h. So we got limit as h approaches 0, we left it's 2x plus h minus 5. So basically limit h goes to 0, so h is just 0. What we left is 2x minus 5, and then we plug f prime 1 into it, which is 2 minus 5, it's negative 3. Alright, the last one. So basically we do the same stuff. We just plug x equals to 2 to the f prime of x. So we solve it for derivative first. And then we minus original function, which is x squared plus 3x minus 5. I skip some steps because if you minus something, you should add a parenthesis to it. But I just I just ignore the parentheses, which means I have to switch a symbol, which means if the symbol in front of the coefficient. So for this one, if it's negative 3, negative, so it becomes to the positive. Positive becomes into negative. Positive becomes to negative. Okay. And then we simplify the equation. Alright, we cancel out x squared with negative x squared, negative 3x, positive 3x, positive 5, negative 5. So we left it's 2xh plus h squared minus 3h over h. So we can easily cancel out the h as usual, just as shown before. So what we left is lim h equal to 0, 2x plus h minus 3. So basically, h is it goes to the limit of 0. So h is just 0. So we get is 2x minus 3. And then we're looking for the slope of tangent line to the graph of f of x at x equals to 2, which means we have to find f prime of 2. We plug the number into it. It's 2 times 2 minus 3 equals to 1. Okay, so we're going to discuss furthermore about the derivative later on, so hopefully you guys enjoy this video. Thank you.